Good evening to everyone. I would like to extend a warm welcome to everyone for this 142nd webinar, a weekly online lecture series, Engineers Talk, being organized by Institution of Engineers, Salem Local Center. I request Engineer S. Loganathan, FIE Chairman, IEI Salem Local Center, and National Council member IEI to welcome the guests and the gathering. Please, sir.
Okay. Thank you, sir. Thank you, Engineer Aramunga, sir. So, we are very happy that again we are meeting all the members through this online technical lecture forum. So, on this occasion, I am very happy to welcome Dr. Pankaj Chaupal from Technical Advisor for Coaching Department of Eastern Railway, Aura, on the very new topic to all of us, evaluation and development of rolling stock in Indian Railways. Definitely very less known to our members are. So we are very eager to participate your lecture. So on this occasion, on all behalf of all the members, I am happy to welcome Dr. Pankaj Chaupal. Welcome, sir.
Okay, thank you, sir. My PPT is visible, sir.
Yes, sir.
Yes,
Yes, sir. Visible, sir. Visible. It is
Okay,
visible.
okay. And sound is
Sir.
sound is also audible, sir, na?
Yes, sir. Sound is also visible.
Okay.
Audible.
Okay, sir. I am starting, sir, within 1 minute.
1 minute, sir. 1 minute, sir. So on this occasion, I am happy to welcome our Honorary Secretary, Dr. Sadish Kumar sir, who has arranged today's lecture. Former Chairman Tangaraj and Lavamani Madam, Honorary Secretary, immediate Honorary Secretary, and senior members like Engineer Muthuswamy and all the members continuously participating this webinar series, and all the student members for their continuous support and encouragement towards the enlightening the engineers through this engineers talk forum in the various topic to know the upgradation of technical development taking in the different disciplines of engineering. So I really thank our Honorary Secretary Sadish Kumar sir once again, and I welcome wholeheartedly all the members, those who are participating in this webinar series. Hope our Dr. Pankaj will enlighten us the rolling stock principles of Indian Railways. So happy evening. Once again, I welcome you all.
Thank you, sir. Now it's my privilege to introduce today's chief guest and guest speaker, Dr. Pankaj Chaupal, Technical Advisor to the Coaching Depot, Officer, Zeal Siding Coaching Depot, Eastern Railway, Howrah Division. Dr. Pankaj Chaupal holds an MTech in Computer Integrated Design and Manufacturing from NIT Jamshedpur and a PhD in Mechanical Engineering from NIT Tiruchirappalli. He is currently serving as Technical Advisor to the Coaching Department Officer at Zeal Siding Coaching Depot, Howrah Division, Eastern Railway, where he is associated with the maintenance and technical management of Vande Bharat Express train sets. His professional interests include maintenance of rolling stock, structural health monitoring, and application of advanced technologies in modern railway systems. With these words of introduction, I would like to invite Dr. Pankaj Chaupal to present on the topic evolution and development of rolling stock in Indian Railways. Over to Dr. Pankaj Chaupal. Please, sir.
Okay, thank you for warm welcome, sir, and very good evening to everyone, including all guest members, faculty members, and student friends. So, in today's lecture, I would like to extend a brief information regarding development of rolling stock in Indian Railways. So, at very first, I will explain what is the rolling stock, and then we will see the how Indian Railways grows since 1853 to till date. So rolling means anything which having circumferential motion, anything which roll. And stock means Indian assets, which include like engines, coach body, and which engines include different types of trains, and these all whatever things rolling on the tracks comes under rolling stocks. So since beginning how the engines are evaluated from steam engines, and now we are moving towards the Vande Bharat trains, which do not having proper engine but which having distributed power supply. How we will see from a single engine to distributed engine how the powers conversion takes place, and how the Indian railways are benefited from these technologies. And also we will see the changes in technological like braking system, as it is a very important aspects of railway from at very first when the steam engine was there, the braking was applied by vacuum braking. Now it is applied through air brake systems, and now finally developed to EP brake systems. We will also see the development of bio vacuum toilet systems and all. So let's moving further. So history of Indian Railway. So history of Indian Railway started in 1832, when before the independence of India, the rolling stocks was used at very first in 1832 in Madras for the transporting of goods. Then in 1853, the first passenger train was run between Mumbai and Thane. That passenger train includes 14 coaches. For running the 14 coaches, they have used three steam engine. So in those days, for running the 14 coaches, they have used three steam loco. You can see nowadays, if the 24 coaches are there, that can run with a single engine. So we will see the how the system changes. And then electrification of the engine started in 1925. The first electrification was done between BT and Kurla. That was 150 105 150 volt DC supply. Then in 1951, the Indian was divided into different zonal railways. If you will see the present scenario, now at present there are total 18 zonal railways are there, and different zonal railways having different functionality and different responsibilities. And in 1984 and present, there is the rapid development and rapid transformation in Indian railways, where the sleeper trains started, followed by AC trains, and development of like ICF coaches, LSB coaches, and all. So these are the introductions. Now, as we know that the trains roll on the wheel, and also we know that like our mobility system, like automobiles, also rolls on the wheel. So it very the fundamental engineering we are going to see here, that is a very basic building block of these Indian railways. So when the car is moving or automobile is moving on the road, to negotiating the curve, they are using differential gear mechanism, as you can see in the figure. But if we see in the Indian railway, we do not having any differential, any mechanism which can negotiate the wheel, because in Indian railway, wheels having fixed structure. If you will see the wheel, with the help of the shaft, or axle wheels are permanently fixed with tight fit. So wheel cannot move itself because as the axle is fixed now. So in order to the negotiate the curve, so if you will see the, like we are going to see a ream is there, thread is there, web is there. So thread of the wheels are at a trapezoidal cross section. At a trapezoidal cross section of 1 is to 20. The main function behind the trapezoidal cross section is, if you roll a cylinder, if you roll a cylinder on a track, it will, what it will go, it will not run smoothly, it will deflected from its position and it will just derail. If you roll a conical object, it will run smoothly. So the wheel shapes are designed in such a way that it will roll on the track very smoothly. So things is very clear that that's why the shape of the thread portion of the shape, wheel shape, is designed into uh, trapezoidal cross section, like conical cross section, and the end portion of the wheels are elongated. You can see there is a elongation portion that called as flange. So the inner portion of the rail is contact with the flange, and the outer portion of the rail is on the thread, like on the wheel. When the wheel moves, the flange the function of the flange is to avoid the train from derailing. So when the train goes on the curve direction, as we can see from the one figure is there. So for negotiating the curve, the outer wheel having the larger radius, if you will see the center of rotation, from the centrifugal force or concept of centrifugal center or center of rotation, the outer portion having higher radius, so it has to travel more revolution. If the basic concept is that angular momentum v is equal to r omega. Angular momentum of both will be same because the speed of the trains are same, but the linear velocity will change. Linear velocity will change and it will help to maintain the negotiation, curve negotiation. So while moving on the curvature, so the wheel will deflect from, like uh, the portion where having, if you will see the thread, a starting portion having less radius and then it will increase, and the near the flange there is more radius. So v is equal to r omega, and omega is function of 2 pi n by 60 speed. So omega will be the constant, speed will be constant, but velocity will be changed as radius is going to be changed. And by using that fundamentals, the track wheel mechanism is negotiating the curve, as but in automobiles they are negotiating the curve with the help of differential mechanism. This is the fundamental building block of the wheel and track mechanism. And because of this and the property of the wheel, there is a this design gives a self-centering property. Because of the self-centering property, it is smoothly moving on the tracks, which is not leading the wheel set to derail from the rolling stock. This is the fundamental behind the movement of uh, wheel mechanism on the track. I hope do you got this point. So this is the some mathematical equation. So angular velocity of the both will be same because the speed of the engine is same, but radius, as the radius of the curvature is change where the r is the track center line radius, and r1 is the r0 is the outer radius, and ri is the inner radius. So radius is changing, but the angular momentum as well as the speed is same. As the radius is changing, the distance is also changing. Because of this, the curvature, the negotiation of the curves has been done by rolling stocks. So as now moving further, the track is also one of the important aspects of rolling stock. So initially, when the track was developed in initial days, the sleeper was of wooden and the track was of the iron. Then it's further developed. Then it's the sleeper was of the like concrete, and the track or rail was of steel. Similarly, we can see from the there are four figures there. The first figure is indicates the initial days of development of the track, then followed by the present scenario, and the third figure is the as the speed is increasing, the track has to be also improved. So this third figure, as my cursor is here, it is showing the track of the metro trains, and as the high speed train is the first high speed train or is going to build in Ahmedabad between or Mumbai. That was the under construction, and you can see the condition of the track. So as the speed will increase, the track has to be also improved. Similarly, the initial days, if you will see the length of the track, in if you will go to like mountain or hill areas or initial days, there was some gauge was there that called narrow gauge. The distance between the track was nearly 762 to 610 mm. So, but a standard track which is followed in Indian railways are like a broad gauge. The distance between the two rail is the like distance from inner portion of the two rail is 1676 mm. So that throughout the Indian railways, 167 mm standard gauge is followed. But however, in the if you will say in like Himalayan railways or Darjeeling railways, there are still narrow gauge trains are there because of this mountain region or hilly regions. Further moving towards the development of passenger coaches, as we know that the first passenger coaches was run between Mumbai and Thane in year 1853. In that, the coach body was made of the wooden. So, in the if the wooden body is there, and coach body was the made of wooden, and it was mounted on the steel frame structure, and the speed of the train was very less. It was nearly 330 to 40 kilometers. The drawback of that train was that because it was wooden, so crash worthiness, poor crash worthiness means when there will be collision, the train will be easily damaged and passenger will be affected. Similarly, wooden is there, it is suspected to the fire hazardous. Passenger comfort was very low, maintenance was as well very high, and during that there was no toilets, there was no bathroom. Further, this was the first generation of trains. Then it was a little developed in the second generation. The coach body was introduced as a steel body, and it was mounted on the the frame, and suspend frame was also is steel and mounted over the steel body. And it having the advantage what the second generation train got, the safety improved, uh, bit suspension was good, and in this first time the toilet was introduced in the system. A speed of the train was nearly 60 to 80 kilometers. So toilet was introduced, but in in those trains toilet was like direct discharge, like when when the train is standing on the platform or when the train is moving in the tracks. So whatever the system used by the flushing, like toilet system used by the passenger, it will be the direct discharge. It will directly goes on the platform or track on it. It's just deteriorates the surroundings. So further, it was developed. The first indigenous train was developed in the year between 1955 by ICF. ICF means Integral Coach Factory, that is situated in the Chennai. So that was the ICF train, as you can see in the figure. The ICF trains sometime looks in the initial days. The ICF train was of like this blue colors. And now and further it was developed, and there was certain modification, and it was converted to light yellow color. So in these trains there was certain features that, so first time the coil spring was used in the train, so it's having certain suspension due to the coil. And as these trains are introduced with a screw coupling, as you see in the first figure, this is the screw coupling. And the uh, braking system was mounted on the like flange. See, like a thread of the wheel. If wheel is there and the wider portion is called as the thread, and the braking system was applied on the thread with the air braking system. uh, it having because it was Indian designed by ICF, so it was a lower production cost, maintenance was easy, and because it was indigenous, and the speed of the train set was also increased to 110 to 130 kilometers per hour. But the limitation of the this train was that when there is a collision, when the train was collision or when any accident takes place, so due to the telescopic property, one coach is inserted to other coach. That is telescopic means when there is train is moving in high speed, and there is a collision, so because of the side portion of train, that is the crash, this portion, one train, like one coach is inserted to the other coach. So because they're having, due to that, there is a probability of high loss of main material and machineries. And also there was the riding index, the riding index, the like it is the overall comfortness of the passengers. So riding index was suppose 3.25 to 3.50, so it was somewhat better than the earlier train, like second generation train. But riding index, if the riding index is lower, it will indicate that the passenger is more comfort. If the riding index is higher, it will indicate that passenger is less comfort. And also one of the drawback of this system was that in initial days, in the the toilet system used by the passenger was the direct discharge. Thereafter there is development in the toilet systems, then there was the control discharge system came into picture. In control discharge system, when the train was moving at 30 kilometers per hour, due to this speed, the like toilet will open, there was some valve is there that will open and toilet will discharge. So in this system, the what is happening, the station premises are not affecting, and little bit cleanness was maintained at the station because of the toilet. And let now and the first time sleeper coaches was introduced in like in this ICM coaches. Then moving to the fourth generation, then Indian government has procured the technology like for LHV, like Link Hoffman Bus from Germany. India has purchased the technology for building the like new version of the train from Germany. And the RCF Kapurthala. In RCF Kapurthala, the manufacturing of LHV coaches has been started. The difference of these LHV coaches with the earlier like ICF coaches, which was the third generation of the coaches, the difference was that in ICF coaches, brake was applied on the thread. Brake was applied on the thread, but in LHV coaches, if you see in the figure like this third figure, if you see the third figure, you can see that the brake disc was mounted on the axle. It, instead of applying the brake on the wheel, it was applied on the disc. So this was developed because when the brake was applied on the wheel, there is will be continuous like friction between wheel and the brake, and causing there is a decrease in the diameter of the wheel, and it will leads to the decrease in the life of the wheel. Generally, if you will see, initial starting of the wheel will be the 950 diameters, and further it will reduce to 825, and at 825 wheel has to be condemned. So this modification has been done in LHB coaches. And LHB coaches also, instead of springs spring systems, air velo system was also further introduced. Due to the air velo system, Due to the air value system, the comfortness level has also been increased. There was a drawback in the ICF train when the one when there is a case of collision. One train is like due to the telescopic nature, one coach is inserted to other coaches. But in this train, instead of a screw coupling, as you can see in the figure one, for in order to coupling means when we are connecting two coaches with the help of a mechanism, that was called coupling. So in that coupling, CBC center buffer coupling is used. The functionality of this couple was cover was that uh, it's having advantage that it's better riding index. Riding index initially it was 3, and now it is decreased to 2.5. So riding index was increased, passenger comfort was increased. Also, but if you see the ICF train, when the train there is a collision, if you see the news or if you see the internet, you will see one coach is clean over the other coaches because of the screw coupling. Because while connecting two coaches, this coupling has to be like tightened. When there is an accident, one coach is like one coach comes over the other coach. But when there is a CVC coupling is used, because of this advancement of CU, so the climbing of the one coach over the other coach is finally avoided by with the help of this CVC coupling. So now, if you'll see the practical applications after mounting the braking system on the wheel, on the like a disc instead of wheel, there is a improvement in the like brake, because in wheel we are going to mount with like a like brake pad is made of the ferrous composite materials. But the life of the brake pad increased, but there has been seen that wheel was damaging, because if brake was applied on the brake was applied on the disc, so there has been cases where seen that there is a selling means the you can understand that there wheel over this portion some material has been removed, that is called a selling. So there is a wheel defect in ICF coaches. When there is a application of brake on the tread, there was no wheel selling. But when there was the application of the brake on this wheel, this brake disc, there was a selling on the thread were found. This was later some again advancement in the WSP or some technology has been brought, and that was little minimized. And the main advantage of that, the ICF compared to the ICF coaches, the speed or the design speed of the coaches was very good in around 160 kilometers per hour. Further, the advancement in the latest generation that we are going that we are seeing since year 2000, the actually development was started in 2019 itself. That is the latest development in Indian Railway, that is Vande Bharat trains. Initially Vande Bharat trains developed, then it was also followed to the Amrit Bharat. Like Vande Bharat trains having fare is very high, so that's why Indian government developed the Amrit Bharat. Amrit Bharat is the fully non-AC trains. The cost of the like fare cost is very low as compared to the Vande Bharat. Then further it was developed to the, because Vande Bharat train was used for the lower distance travel, like one day journey. So for accommodating the higher long route journey, sleeper Vande Bharat trains are now being developing. Two sleeper Vande Bharat trains so far has running. So that Vande Bharat is currently running between sleeper Vande Bharat is currently running between Kamakhya and Howrah. So now I'll discuss the advantage and technology of the this Vande Bharat trains. So advantage of Vande Bharat trains, if you will compare the conventional train, either it is ICF train or it is LHB trains, we are seeing that every train we are mounting on engines, separate engine is there. and separate engine is there. Then with the engine, we are arranging a coupler. We are arranging a coupler to the coach. Through that engines to the coach, power supplies are going, uh, and then AC, fan, light, all will work. And also, if you will see the conventional train, there is the power car or DG generator. Additional coach is additional coach is fixed on the generator, on the engine backside. So in that, if there is no power supply, then we have to run that engine, and power will be like for running the AC, for running the light and fan, the power will be accommodating from that DG. So in Vande Bharat trains, those things are avoided, and we can see that in Vande Bharat trains, system is designed such a way that all the like motor, transformer, pantographs, or are all are designed such a way that all the heavy equipments are fixed on underslungs. If you will see, the main advantage of Vande Bharat train is there is no separate locomotives need to be attached in the Vande Bharat trains. So what is the advantage we are getting? So we are taking less station space. If, because suppose 24 coaches train is there, in that there will be one engine will be there. So that space is minimizing in Vande Bharat trains. There is no need of engine, so we can accommodate, instead of the space, we can accommodate some passenger, around 60-70 passenger, because DTC coach is having 44 number of seats. So one is that advantage. Second one is the distributed electrical traction. Actually, in Vande Bharat trains, if you will see this bogie, if you will see the bogie in if you'll see there is 16 coach Vande Bharat train is there. So Vande Bharat trains is divided like four trains unit. So first four train is one unit, second four coaches is one unit, third four coaches is one unit, fourth four coaches. In one unit there will be two coaches in which underslung motor is mounted, motor and gear assembly. Initially, in locomotive, motor and gear assembly was mounted, but in Vande Bharat trains, in this bogie itself, gear and motor assembly was mounted. So what is happening? Every other coaches, in every alternative coaches, in that way we are getting every alternative coaches having one motor coaches through which power is supplied. That's why we are saying distributed power supply. So the total efficiency you will be seeing. So the 16, if 16 coaches Vande Bharat train is there, then there will be the 8 coaches having motor. So the power supply will be the 50% of the coaches, and remaining 8 coaches, there will be the one will be the driver coaches, in which driver is sitting for the operations. Similar, in backside there will be also driver coaches. And one big advantage we are also getting, if you will see the conventional train, if it is going to the terminating station like Visakhapatnam, so engine has to be open, and again one new engine has to be fitted in the front portion. So because of that, there is a loss of time, loss of manpower. But Vande Bharat, there is nothing like that. If you want to run from any either of side, you can run. There is the time wastage or the manpower wastage for the connecting of the locomotive with the rake is avoided in the Vande Bharat. And then there is a coming to the interior of the Vande Bharat trains. If you see the interior of the Vande Bharat trains is equipped with the modern technologies, like it is equipped with the CCTV camera. If in route any abnormalities or any case of theft is happening with any passenger, they can simply lodge a real Madad complaint, and that real Madad complaint will be investigated by the concerned RPF department. And if somebody has lost anything, that can be regained. This is the one advantage of the Vande Bharat trains. That one is the GPS based passenger. The latest development is the GPS based passenger. And if the Vande Bharat train is running, suppose I am sitting in a room, Vande Bharat train is running, suppose somewhere. If we want, if by using computer, we want to see the what is the speed of the train, how much energy Vande Bharat train is how much voltage is supplied to the Vande Bharat, how much energy is regenerated from Vande Bharat, what is the temperature of motor of the Vande Bharat, what is the temperature of the coaches, at what temperature is what is the AC temperature, what is the speed, if, because as this systems is designed by feedback systems, so we are getting all those feedback. If in route, if any problem is there, by help of the our present computer or like a loconet system, there is a, for monitoring all those things, the system is used, that is called loconet system. We can monitor everything. So in a route, if there is any failure is there, so with the like control system, we can suggest that there is a problem in these coaches, you can go and you can rectify. One of the big advantage of the Vande Bharat train is there, it is a regenerative braking system. So earlier those trains having like air braking systems, through that there was no power generation. But in Vande Bharat train, at the initial at the initial position, suppose when the braking is just started, if you will see the driver desk, there will be one throttle handle is there. If the braking is just started, up to 33% of the movement of the throttle handle, so you can see that there is a regenerative power generation. Regenerative power generation means the power is supplied to the OHE, and through it will going to the powerhouse, and thereafter again the power is can be used, reused. Power can be reused. That is one of the big advantage of the Vande Bharat systems. One of the advantage is the aerodynamic design. Aerodynamic design means you, because of this aerodynamic design, you can see the nose cone. Aesthetic appearance is also good. And while when the passengers are on the on board, they can uh, easily travel from one coaches to other coaches, because between the two coaches there is one gangway is there. So the gangway is designed such a way that there is the higher safety. Air ingress is also, there is no air ingress through the gangway. So this is the one of the biggest advantage on. And now coming to the toilet systems. So just I will explain about now. Direct discharge to it's came to the control discharge. Then DRDO comes into the pixel. There was one Indian Railway and DRDO, one MU was signed. So there was a development of bio toilet systems. So with the help of DRDO has developed a bio toilet systems. So now in Indian Railways, so all the toilet systems, all the chambers chambers has been replaced with bio toilet systems. In that chamber, there are the say, six, seven separate chambers are there. If you will see the Indian Railway toilet box is there. So inside the box, there are seven separate chambers are there. In every 1 month in Vande Bharat, generally in 1 month we are filling the bacteria. Like bacteria was purchased from any firm which is nominated by the RDSO, and we are pouring the bacteria into the like toilet systems. So what is going, if any solid waste are there, the bacteria will convert those solid waste to the liquid or liquid and gases. Through that, now we are approaching the maximum cleanliness in the Indian Railway. If you will see the 10, 15 years back, the platform, the track was very dirty. Now, if you'll see, there is a those things are avoided with the latest development in the technology, as the bio toilet system has been upgraded. Now in Vande Bharat we are using advanced version of the toilet. Like in the ICF train, if you will press the button, water will supply for flushing. In the LHB train, if you place the button, water and air will be supplied for flushing, like pressurized air. In the Vande Bharat trains, there is advanced version of the bio evac system is there. If you press the button, very low amount of the water is used for the flushing. So water consumption is also minimized in these trains. And also there is the advanced development is that fire detection system is there. In if any smokes or any fire is detected, suppose if train is running and there is a short circuit in the rake in the train, so due to the short circuit there will be little or more there will be emission of smoke. So the system is designed that it will that those smoke will be detected, and that message will be given to the driver that there is a certain smoke or abnormalities in the coaches. It will also indicate the in which coach there is abnormalities there. And in Bande Bharat, CCTV system is such a way that the coach which are suspected will reflect on the screen very fast. If the coach is there, if the Bande Bharat system CCTV system is designed such a way that if there is any abnormalities in the train, the that abnormal situation will be reflect on the driver's screen. So by seeing that, driver can easily analyze. Or there is in also Bande Bharat, there is one special feature as the passenger talkback unit. If any passenger want to communicate with driver, any medical emergency is there, any other emergency is there, they can simply press a button is there, ETBU button is there. If you press the button, the call which will go to the one side is driver, other side is the guard. As driver is busy in the train moving operation, it will go to the guard. You can complain to the guard for any abnormal situations. So accordingly, by guard will take the action. In if you earlier slide you have seen that brake was applied on the first wheel and then second disc. And in the Bande Bharat, the brakes are applied on the actually brake disc is mounted on wheel itself only. So achieving the higher braking effect. In this, air brake system is also there, and electro pneumatic braking system is also there. So braking system is also improved. Coming to the passenger amenities, the passenger in chair car Bande Bharat, 360-degree rotating chairs are there. If you are in traveling in the executive class, you can rotate the seat in 360 degrees, and you can enjoy the appearance of the through windows. So however, coming to the sleeper Vande Bharat, the mechanical technology is almost same in the sleeper Vande Bharat. The same wheel, same bogie is used in the sleeper Vande Bharat. But only the difference between the chair car Vande Bharat and sleeper Vande Bharat is that design of the passenger area is makes such that the passenger can use for sleeping purpose. Design of the seat are different. Design of the toilets are almost same. IC doors are almost same. And this figure is the Amrit Bharat trains. Amrit Bharat trains, like in compared to the normal trains. In normal trains we are using one engine, for moving the wreck. In Amrit Bharat trains, both side two engines are used. In front side engine was also used, and back side engine was also used. So it is also on the concept of the Vande Bharat only. But thing is that additional time requirement for the opening and closing of the engine with the rake is minimized. So this is the advantage also. And as earlier I have told that the price of the Amrit Bharat trains, for fare of the Amrit Bharat trains are much a small amounts compared to the sleeper or chair car Vande Bharat trains. Mainly this trains is developed for the lower middle class people of India. So this is the how the Indian railways developed from if you see the toilet system, how the toilet system is improved from direct discharge to the bio vacuum systems. Similarly, how the Indian railways was improved from the engine based system to the distributed power supply based systems. So we have seen that. Now we will in the next slide we will see the uh, opportunity like governance and hierarchy of the Indian railways. If suppose this slide is beneficial for the student, especially if you want to work in Indian railways, so how the opportunities are, I want to discuss in this slide. So I will start from the bottom. Actually, the bottom hierarchy in the bottom, at the lower level management, like lower level, the peoples who are working like technician, trackman, train manager, loco pilot, station master, TT, office staff. So for in Indian Railway, the most of the cadres are occupied by these peoples only. Like if you, I do not exact percentage, but I hope more than 95%, 90 to 95% are equipped with this the lower, like technician, track manager, and all those things, lower level management, like lower levels in hierarchy of the lower levels, which is directly engaged in the running of the Indian railways, like maintenance of the track or maintenance of the trains or train movement. Then for joining these cadres, different when the vacancies are coming for different posts, there is different qualifications are there. But if you see the general qualification, if you having 12th 10th plus ITI or 12th plus ITI, you can start your career in the Indian railways. If you are graduating of many universities, so you having option for the joining the supervisor cadre as well as the joining the officer cadres. In supervisor cadres, actually these all like technician, trackmen, etc are managed by the supervisor cadres. Supervisor cadres is playing a the key role in the Indian railways to manage the to stabilizing the coordination between the officers and the staffs. So joining the, actually the qualification required for the supervisors is starting with diploma. Even though most of the BTech holders are working, actually most of the BTech holders are working only because you know that there is huge competition in India. So supervisor cadres is there. Then above the supervisor cadres, there are the assistant officers. In Indian Railway, 70% of the seats are filled with the direct recruitment through UPSC. UPSC through Indian Engineering Service Examination, or IES, Indian Administrative Service through IES. Also Indian Railways recruiting like personal departments. So the officers, the actually officers the officers grades are started from assistant officers grades. The officers who are joining the Indian Railway, they will be the initially assistant grades, then it will be promoted to the divisional officers, then it will be promoted to the senior divisional officers. If you'll see the department of the Indian Railways, there are engineering department, mechanical department, electrical, S&T, operating, commercial, personal, finance. There are a lot of there are huge number of departments are there, and there is the coordination between each department is required for the smooth running of the Indian Railway. Because if you will see the engineering departments, they are engaged with the development of the track or development of the building structures. If you see the mechanical department, they are engaged with the development of the rolling stock. And if you see the electrical department, they are mainly dedicated with the like development of OH overhead equipment systems, development of light and AC in the trains. SNTs are playing a key role in the development of the signaling system. Now advanced, initial there was the signal was the some manual signal was there. It was on and off by the operating manual. Now there is advancement in signaling system. Now it is automatically, there is automatic signal systems are there in operation. Operating department role is that it will be engaged in the operating like driver, in which track the train will be going to move, in which platform the train will be going to lie, and all. Commercial department is associated with the booking of the tickets or checking of the ticket during the train operations. Personal department is engaged with the recruitment process, and also like staff assessment, like HR department, human resource department. And coming to the finance department is of coordinating with all financial activities, whatever the money engaged on the development works, staff salary, and etc. And all this department works under the divisional railway manager. So every organization, every journal having some divisional, actually every zone has been divided into some division, and that division was monitored by the DRMs. And this DRM is the control of zonal railway manager. And like in India, there are 18 zonal railways are there. And in 18 zonal railways, there are different, in each zonal there are, like if you see the Eastern Railway has been divided into four divisional railway. So divisional railway has headed by the DRM. So finally, this zonal railway will be the under the guide, will work under the guidance of the railway board. And then final will be the Ministry of Railway and Government of India. Apart from the zonal railway, there are the production units like ICF, CLW, DLW, RCF, NCF. The production unit means who are directly engaged with the production of the rolling stocks. And coming to the other organization are also there, who are training the engineers, like our RDSO. They're training the engineers, making the rule regulations, making the design, and all. Like RPF department is also there, that is other department is there, that is for the security purpose. So this is the overall department. If somebody want to actually, and the promotion from the, it's as we know that promotion goes in up directions, from divisional managers to, if based upon the qualifications, grading, and their department capabilities, people are moving forward to the development. So with this, I would like to conclude my talk on this development of rolling stock. So thank you everyone. If you have any question, please feel free to
Thank you, sir. Thank you, Pankaj sir. This is Loganathan.
ask. Okay, sir.
Very excellent narrative and very informative, sir. Your talk is from starting of railways to how it is evolved, how many generation we have developed the coaches, and engineering point of view also. It's really a very good information you have shared, organization structure, everything. Thank you very much. Really, it's a wonderful session. We received many information, especially that inner track, outer track. So in the curve, the outer track will be a lengthier, longer one, like that. And organizational chart, how the coaches evolved from wooden to present Vande Bharat train. Excellent, sir. Excellently presented. Very informative. Thank you very much for sparing your time.
Okay, sir. Thank you, sir. Thank you very much, sir.
Thank you. Thank you.
Okay.
Any other queries?
It seems there is no. So shall we conclude, sir?
Yes, sir. Yes, sir. Okay, okay.
Yes, sir. Thank you, sir. Thank you very much for your informative and a wonderful presentation on the topic evolution and development of railway stack in Indian Railways. And I would like to invite now Dr. R. Satish Kumar, Honorary Secretary, IEI Salem Local Center, to propose vote of thanks. Please, sir.
Yeah, thank you, Arumugam sir. Very good evening to everyone. I'm very much happy to present a vote of thanks. At the outset, I am very much happy to thank our chairman, engineer S. Loganathan sir, for his warm and kind welcome address. Thank you, sir. Next, I would like to thank today's chief guest, keynote speaker, Dr. Pankaj Chaupal sir, technical advisor to the coaching depart, officer jail siding coaching depart, Eastern Railway, Aurora Division. Sir is very kind enough who accepted our invitation immediately. And thank you very much for sparing your valuable time with us. As our chairman and Arumugam sir told, it's very insightful and very informative sessions and complete generations of the railway system, including administrative structure. You elucidate in a great way. Thank you so much. And also I thank Thirumalai sir, who is a friend of mine working in Trichy Ponmalaipatti workshop. Through him only I connect with Dr. Pankaj sir. I submit my thanks to him also. Thank you, Pankaj sir, for your valuable timing with us. And also
Okay.
yes sir. I
Thank
also
you, sir.
thank, yes sir. I thank Engineer Stock Committee members, Dr. K. Tangaraju sir, immediate post chairman, Dr. C. Davamani madam, immediate post honorary secretary, Engineer N. Armugam sir, Dr. A. Kumaravel sir, Dr. N. Senthil Kumar, Engineer INR, and all senior committee members, corporate members, and all my dear student friends, staff members, everyone who made this program such as one. Thank you everyone. Thank you all. Pankaj sir, once again, thank you so much.
Thank you, sir. Thank you, sir. Thank you.
Yes, sir. Super presentation, sir. Thank you.
Okay. Thank you, sir. Thank you.
Yes, sir.